Okay, guys, so I had to regroup real quick because no one showed up for the morning block for retesting. And so what I'm doing now is I'm going to record the lesson for today's math block for the kiddos that are finished. And the kiddos that are not finished with testing, those kiddos are going to stay with me and we're going to do math. We're going to do our testing, our makeup test for NWEA. With that being said, you must watch the entirety of this video. We're going to go over page 417 through 422 in your My Math book. So take that out, click pause please at this time to get out your pages, and we're going to go over it. And then my kiddos that are testing, they have the afternoon to make this video up. Okay, so let me go ahead and put my camera on. Hopefully, yes. For my premium camera, it's going to come work. There it is. Okay. So again, we're on page 417 of our math book, and it's called Problem Solving Investigation, Looking for Patterns. Once again, we're working on multiplication of decimals with whole numbers and decimals with decimals. Let me try to make this a little bit better. There it is. Okay, so understand, learn the strategy. The table shows the amount Hank pays for his clothes and the amount of discount. How much will he pay and how much will the discount be for a shirt that costs $34.70? And I want you to note that a lot of the problems that we're dealing with are with money. And in money, you go from tens and hundreds, right? Those are the two areas where you're focused on till this part, right? Most money values are in the tens and the hundreds. So for instance, we have in change wise in our money system, we have pennies, which is in the hundreds place. We have nickels, which is also in the hundreds place. We have dimes, which is in the tens place, and it's also worth 10 cents. So that makes sense. And then we have 25 cents, which are both in 2 in the tens and 5 in the hundreds. Okay, facts. What facts do you know? Hank will receive blank on his shirt. So the table shows the amount. So he pays boots, $68. He has a discount of $6.88. His final cost is $61.92. His jacket is $62.30. He gets a discount of $6.23. And his final cost is $56.07. His pants are $48. He receives a discount of $4.85, and his final cost is $43.65. And the question at hand, how much will he pay and how much will he discount be for a shirt that costs $34.70? Hank will receive a blank on his blank, so a discount on his shirt, right? I'm not going to fill this out because it's not really needed. What do you need to find? I need to find the amount Hank will pay for the shirt. I just have to write it, I don't know. Okay, look for the pattern. Extend the pattern to find the cost. Multiply the cost of an item by blank to find the discount. Subtract the discount from blank to find the final cost. So we multiply the cost by the percent to find the discount. Subtract the discount from the cost to find the final cost, the original cost to find the discount. So in this case, $34.70. So let's look at a pattern. So $6.80. Oh, do you see it right here right away? Does anyone see it? It's a base 10 number, right? So you went from 68 to 688, from 62 to 623, from 48 to 485. So from 34, your discounted is going to be $3.47. But what are you really doing? You're multiplying by what? And you think about it. What are you multiplying by? If you multiply by 10, it's getting bigger, right? But if you multiply by that, though, it would be $3.47. The discount is $3.47. So when that is discounted, and I don't want you to do it because we did not go over that part. We skipped it, so we're going to go back to it. Okay, so let's go to the back. Apply the strategy. Every year, Victoria receives $30 for her birthday, plus $2 for every year her age. Lacey receives $20 for her birthday and $4 for each year of her age. In 2013, Victoria was 10, Lacey was 6. In what year will they both receive the same amount? So let's think about it. So this is Victoria, right? Victoria receives $30. That's a base of $30. And then it's $2 for every year. Okay, so then we look at what Lacey's receiving, and Lacey is getting $20 for her birthday and $4 each year. So $4 for each year, her birthday. In 2013, Victoria is 10 and Lacey is 6. And what year will they both receive? So Victoria in 2013 is 10 years old. So Victoria gets $30 and she's 10 years old. So 10 times 2 is 20. So she gets a total of $50 a year. Now Lacey, she gets 20 and she is 6. So 4 times 6 is 24. So then she gets 44. Now let's look at 2014. A year later, she still only gets $2 more. So $52 for Victoria. And for Lacey, she gets $4 each year. So next year she'll get 48. And again, next one, it's going to be 54. And for Lacey, it's $4 more, so 52. The next year, she's going to get 58. Oh, no, sorry, 56. 56 in this 2015, 2016, 56, and she gets 4 more. Oh, 56. So in 2016, they will both receive the same amount. Okay, let's look at the next one. Trent lifts weights 7 days a week. Sorry, I just noticed it's kind of blurry there. Trent lifts weights 7 days a week. He spends 18 minutes, so 7 days a week. He spends 18 minutes lifting weights on Monday, 29 minutes on Tuesday, and 40 minutes on Wednesday, and 51 minutes on Thursday. If this pattern continues, how many minutes will Trent? So let's look at it. So Monday, Tuesday, Wednesday, Thursday, and Friday. So he goes Saturday and Sunday. So he does it every day. Sunday. So Monday, he does 29. Tuesday, okay, so 18 minutes, sorry. I knew I did something wrong. 18, then 29, then 40, then 51, okay, so what is the pattern? What's the difference between 18 and 29? Between 18 and 29, what's the difference? What's the difference between 21 and 40, 29 and 40? How about 40 and 51? So let's look at maybe addition patterns. So from 18 to 29, it's 11. So I add 11. From 29, oh, I add 11. From 40 to 51, I add 11. Oh, okay, I see a pattern. So then Friday, he does 62 because I add 11. And then Saturday, if I add 11, I get 73. So 73 minutes on Saturday. I think this is why math is so fun, because it's like a big puzzle that you're trying to solve. Okay, so it says find the missing numbers in the table, then describe the pattern. So if I put in 5 and I get 9, okay. But if I add 4, this wouldn't work because if I put in 10, I get 19. What can it be? What can it be? What do you notice? It's not an addition pattern, right? Because this one I would add 14. So it's a machine, right? And in this machine, it's called a number machine. You put in a number and a number comes out. And so this little number machine has a code that it's following, and it's doing the same thing to every number that comes in. And so it wouldn't make sense if I'm adding 4, because in this one, I don't add 4 and get 19, I would get 14. And in this one, I don't add 4, I would get 24. But I do notice something. If I double this, I get 10, but that's 9. That's one less a double. How about if I double this? If I double 10, I get 20, but 19 is one less. If I double this, it's 40, and one less is 39. So if I double 30 and 15, it's 30, and one less is 29. If I add 1 to this one, it's 50, and half of that is 25. Will that work? Double 10 minus 1, 9. Double 20 minus 1 is 19. Double 30 minus 1 is 29. Double 20, 40 minus 1 is 39. Double 50 minus 1 is 49. It does. So you double and take away 1. Okay, look for the pattern and below, then find the 3 next numbers, okay? Ah, I see, I see. Think of base tens. What are you doing? You are multiplying by 10 each time you move, right? So you multiply by 10 to the right, one time. Multiply by 10 to the right, one time. If you multiply by 10, 3, 30. If you multiply by 10, 300. If you multiply by 10, 3,000. If you multiply by 10, 30,000. So every time you are multiplying by 10. How about this one? You're moving the decimal to the left, right? Every time you're moving the decimal to the left. So this one's 7, 8, 4, 5. One time to the left. And if I move it to the right, the decimal, I'm multiplying, I'm getting bigger by 10. So the opposite of getting 10 times smaller is you're dividing by 10. So let's look at this one. Samuel will arrive at the airport on the first plane at 10 a.m. Airplanes arrive every 50 minutes beginning at 6 a.m. When will Samuel's plane arrive? Okay, so he's gonna arrive for the first plane after 10 a.m. Okay, so they get there. So I'm gonna start off with 6 a.m. And when I add 50 minutes, 6:50 is one of them. But remember when we talked about thresholds of place values, and then usually the place value threshold is 9. In this case, it's minutes. What's the maximum amount of minutes that I can have in an hour? 60, right? And so I have to add 10, right? Add 10 to get to 60, and that's 7. And I'm adding my 40 left. Okay, when I add, if I'm just adding 60 minutes to this one, or what is it? Is it 50 minutes? I get 7 hours and 90 minutes. Oh, I can't do 90. The max is 30, so that would mean I have to push it up to 8 hours and 30 minutes. If I add my 50 again there, I would see that it's 9 hours and 20 minutes. If I add my 50 then, I would see my 10 hours and 10 minutes. Hey, do you see the pattern too? 50, 40, 30, 20, 10. So Samuel's plane would arrive at 10 a.m. On Serena's 10th birthday, her mom was 3 times Serena's age. How old? So Serena is 10. Her mom is 3 times her age. 3 times 10 is 30. How old will Serena and her mom be when her mom's age is 0.5 equal how old will Serena and her mom be when her mom's age is half will equal Serena's age? So they want to find off when they will make perfect halves. So let's look at it. So if I add 1 year, one is going to be 11 and the other is 31. Then the next year, sorry, I should do it like this. 11, Serena and mom, and one's going to be 31. Oops, let me zoom it in, sorry guys. And then the next one's going to be 12 and 32, 13 and 33, 14 and 34, 15 and 35, 16 and 36, 17 and 37, 18 and 38, 19 and 39. This one's interesting because they will never be half the same age, right? They're always going to be 20 years apart. Let me think about this one. I'm going to think about this one, guys. Okay, so Mindy reads 8 pages of her book the first day, 15 on the second day, and 22 pages on the third day. If the pattern continues, how many pages will be read on the 6th day? So on the first day, she reads 15. On the second day, on the first is 8. On the second, 15. On the third, 22. On the fourth, on the fifth, and on the 6th is what we're looking for, right? So if I add 7 here, that works. So 29, 36, and add 7 to that one, I would get 43, right? 43. So 43 pages. So I think the biggest thing with these kind of word problems is to make sure you are drawing something out that you can picture. So, for instance, a mile hike path has signs placed every 240 feet. There are signs placed at the beginning and the end of the mile. How many signs are there? So, whoa. This is a mile, right? And then let me zoom out. This is the mile. And every 200 feet, 240 feet, there is a stopping point where there's a sign. And they want us to figure out how many total will there be. So then the next one is 480. Then the next one is from 240 is 720. And the next one, if I add it, I get 960. And the next one, if I add it, I get 1,200. I like that number. Okay, and the next one, when I get to 240, I get 1,440. And the next one, when I add 240, I get 1,680. And the next one, when I add 240, I get 1,920. In the next one, when I add 240, I get 2,160. In the next one, when I add 240, I get 2,400. And the next one, when I add 240, I get, did I do something wrong? Let me just check real quick. 240, 240, no, 240. I get 2,640, 240, 2,880, 240, 3,120, 240, 3,360, 240, 3,600, 240, 3,840, 240, 4,080, almost there, 240, 4,320, 240, 4,560, 240, 4,800, 240, 5,000, oopsie, 5,040, 240, 5,280. Now I'm going to count how many total places I had. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 total signs. And I'm just looking at time, guys. It's already 9:25 when I'm recording this. So I'm not going to do 10 or 11. But your independent practice when you are ready to go is going to be 1 through 5. Don't do 4. So it's 1, 2, 3, and 5. Okay? Thank you, guys.